CloudDB, shaping your new normal.
Welcome everyone to the 2021 APEC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you can watch the replays to the sessions you are registered to up to December 30 through the platform. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, on-premises or Oracle Cloud, how to build a high available and scalable logistic platforms with Oracle 19c and Goldengate in 19 or 21c by Nikitas Xenakis. Please feel free to ask questions at any time by using the chat window in the right lower corner of your screen. And Nikitas will be answering all your questions at the end of the session. If you have any issues during this session, please feel free to use the same chat window to contact me, and I will try to help you the best I can. Without any further ado, I would like to leave you with this amazing session by Nikitas Xenakis. Nikitas, the room is all yours.
Thank you, Francisco. Thank you for having me. It's a pleasure to present to everyone. Good morning, good afternoon, good evening, whichever time zone you're joining from live, or hopefully you'll get the chance to see this as a playback if you can't catch the session. My name is Nikitas Xenakis, and I'll be taking you through in this session how to build a highly available and scalable logistics platform for your mission critical systems with Oracle 19c, Goldengate 19c, or 21c, a latest development in the Oracle Cloud. And you can do that either on premises or in the Oracle Cloud. Just a little bit about me. I'm a principal architect at the Co-op, a UK leading convenience retailer. I've been an enterprise DBA for more than 20 years, and recently moved more into an architect role. Versions from 7 all the way to 21, so you can tell I've been doing this for too long. I've been doing some advisory with a key Oracle product set, especially in the MAA group, Oracle Database, Oracle RAC, data integration through the Goldengate suite. And I'm also part of the Global Leaders Database Development, part also of the Oracle ACE program. So if you are part of the community, but not just that, please feel free to get in touch. These are my social media handlers, Twitter or LinkedIn. Please feel free to connect, and we can catch up. And it's great to be part of this community. A little bit about our agenda. I'll take you through some business context on how this has come about. Also, pardon me, the as-is and the target architecture, where does Goldengate fit, and how we've introduced it and deployed it in its various versions and incarnations through classic and microservices. A little bit about multi-tenant and autonomous. How do we do disaster recovery? A few lessons learned, and hopefully you'll have the chance to answer your questions. But what about the co-op? Well, we've been here since 1844. As I said, it's a major UK retailer. This is how our stores used to look like, and this is how they look today. Top end in the 1800s. Right at the bottom, how we now look, and it's been set in Rochdale, a small town outside of Manchester, in the northwest of England. But what does the co-op look like in 2021? Well, that's our beautiful support center or head office, however you want to call it. We've got a leading convenience retailer with an annual revenue of just over 15 billion. We've got a mixed estate of our own stores, but also in terms of our proposition, we are in the retail, wholesale, franchise, and e-commerce and home delivery game, I suppose, or proposition, if you like. We've got 14 currently distribution centers, onto our 15th in early January. And our logistics network, which is very important, and hence the reason for this presentation, distributes products onto in excess of 10,000 outlets, which span this business proposition. So you can imagine how important that logistics platform is. But what does the business ask us constantly? Well, number one, the business wants to grow. So we used to be a retail mainly business. Now we are expanding into new channels, so wholesaling, franchising, e-commerce. With COVID, we shifted a lot of our demand from the bricks and mortar onto the home delivery. But how do we do that? Well, we use technology in many different ways. We use it as an enabler, but also we use it as a transformer. So we can't, in cases where we can't take cost out of the business by driving efficiencies and reinvest that, then we use technology as a transformer, with things like AI, with ML, and all these brilliant new technologies. So this is kind of what that looks like. So just a small example to give you this on the top, on the bottom right is our chief exec, Joe Whitfield, showcasing our green bicycles for delivery into your home. So we're trying to lower our carbon footprint, at the same time provide everything that the customer needs, but in a green fashion. Another cool technology we use is the Starship, which is an autonomous robot. So basically, we're piloting this in a couple of councils in the UK. You place an order through the app. We pick it at the store. We place the items into the autonomous robot. The autonomous robot will deliver the items at your doorstep with the app. You open the door to the robot, and you collect your items. Safe, secure, fully efficient, and also very green. So our technology and business landscape, as you can imagine, with all these initiatives, is growing and growing. We've got 2 data centers 12 miles apart. We've got footprint in all major cloud vendors, AWS, Azure, and Oracle Cloud Infrastructure, OCI. We've got a huge, quite a significant support center with 4,000 users that we need to support. We've got 14 into 15 distribution centers that support the logistics network. And then, as you can see, there's various stores that we deliver to through our network. So that's 2,800, which are our own, and 2,200, which are wholesaling, 4,000, again, wholesaling, and then the independent stores through franchising. We do have in excess of 6 million members and 70,000 colleagues that we support. So the one thing all these initiatives rely on, that I've just demonstrated to you, is a highly available and scalable logistics platform. As I briefly explained, we cover pretty much the whole of the UK. We have a store in every UK postcode, so you can imagine how complex this is. This isn't a small set of big supermarkets in a way, but it's a local convenience. So that's pretty much all over the UK. And in terms of the platform's demand, we are, if you are in the supply chain or logistics domain, then we're talking about in excess of 13.5 million cases. That translates into, billions and billions of transactions every week. And the demand for that is that 98 to 99% of these picking transactions must complete in less than a second, or else we'll lose, significant productivity at every depot or at every distribution center. We do run pretty much in excess of 550,000 real-time operational reporting requests on a daily basis. So why invest in high availability and maximum availability architecture? Well, back to our original conversation, we've got a big logistics network which needs to operate in a highly productive fashion. So the cost of, when we sat down with our logistics colleagues and supply chain colleagues, we quantified what does it mean to them for the system to be down. So their key system is the warehouse management execution system, which basically is responsible for receiving goods and sending goods out of the depot. So receive and send, just to keep it quite simple for the audience. So the cost of 20 minutes downtime for that system per depot is in the high five figures. That is cost that isn't necessarily loss of revenue, because we can't, really quantify that. So it could be a lot more than 5 figures. This is just cost associated with people on the floor. So our colleagues not being able to do their day-to-day job. So this is just pure payroll. Cost of 20 minutes downtime per 7 depots, and I'll explain why 7 depots. Because we are servicing 7 depots out of 1 data center specifically, is in the 6 figures. Anything longer than 20 minutes per that 7 depot set is in the millions. And anything more than 1 hour of downtime, it's incalculable, because, as I said, it's not only the fact that we lose productivity, we start to lose huge revenues. So the platform needs to cover for data center outage, hardware failures, component failures, system failures, and obviously human errors, because humans can also damage the platform or the system. But we're not only investing in high availability for those reasons that I've just explained. We're investing in scalability because we want to open more distribution centers. Through our logistics transformation program, we want to push more load onto the existing depots or distribution centers according to demand. And the asterisk here relates to COVID. If you can imagine, since March 2020, we've had pretty much every day for at least 7 or 8 months running as a Christmas Eve days, because of the panic buying and people actually constantly filling their homes because of the uncertainty. So we had to, and the platform was able to cope with not a blip because of the way we've built it. It never suffered a minute of outage, and it never suffered any scaling issues. The ability to operate and scale our wholesale, as I said, because we're growing, capitalize on acquisitions, because we, from time to time we acquired companies, but also grow and the franchise and home delivery model. So again, scaling, super important for us. And how did we do that? Well, we've invested in the maximum availability architecture, the platinum level. Hopefully, you're all familiar with MAA, but if you're not, I will give you a whistle stop tool of that. It's mainly a set of blueprints, tested blueprints and reference architectures. It's focused around HA, DR, and scaling. It can be applied in either on-premises OCI. It can be applied in commodity, engineering systems, Oracle Cloud, virtual, bare metal, and it's a tiered architecture based on your importance and your criticality. It starts with bronze, with kind of low-level availability requirements, all the way to platinum, which is where we are, where you've got pretty strict availability requirements for your mission-critical platforms. And how is that driven? Well, it's driven by a few factors. RPO, which means how much data can you afford to lose? Well, it's 0 for us. RTO, or recovery time objective. Sorry, I should have said recovery point objective, RPO, or recovery time objective, which is around downtime. How quickly should I be back up, in a component or in a data center failure? Well, it's 0 for us as well. Performance. So if you are losing, let's say you have lost either a component or a data center, what should your performance be after the event? Well, in our case, it should be no different. So whether I'm in full production mode, HA, or failover or switchover, the performance should be exactly the same. And then the perceived application outage. So in some systems, you hide that from the user, or in some cases, you want to let the user know that something's happening behind the scenes in terms of the perceived application outage. Is it transparent or not? So our strategic architecture on premises, excuse me, we've got, if you are running it on 2 data centers, and this is our architecture in our data centers, you've got an OHS layer at the DMZ, fronted by NetScalers. Then we have a at the application tier, a multi WebLogic node cluster, 3-node WebLogic cluster, fronted by an OHS layer. Those domains are independent, so you can run your systems independently. There is no stretch clustering in this scenario, and you've got a minimum 2-node rack cluster with either a physical or an active standby using DataGuard, and also Goldengate in our special cases where we replicate, where 2 use cases apply in Goldengate, either replicate for synchronizing transactional for real-time operational reporting and analytics, or perform online upgrades using Goldengate. In terms of our recent thinking in translating, if you like, or applying those principles and that architecture into OCI, well, the architecture looks a little bit different. We have removed the OHS layer, fronted by the load balancer as a service offering from Oracle, which is an Nginx engine behind the scenes. Very simple to set up, very simple to use, very simple to configure, but still underpinned by a 3-node WebLogic cluster, and the kind of through DBCS, a 2-node rack cluster with DataGuard and Goldengate, active DataGuard and optionally and Goldengate in some special cases. So just to summarize, our preferred patterns is to use, with 19C, obviously, we can use up to 3 PDBs in 1 CDB. With WebLogic and GridLink, use GridLink for our JDBC. If you are using a WebLogic or a Java-based application, or use the corresponding Oracle client if you're using a non-Oracle middleware, but also Active DataGuard and Goldengate for your special cases. So these are the kind of the preferred patterns that we that we use. If you need to share any external files at your application layer, then we use ACFS, a cluster file system, and HNFS by presenting that into your application layer. That way, you've got a highly available NFS layer. 1A and 2 are also valid patterns for bronze, silver, and gold. In OCI, things look pretty much the same in terms of the DB layer. On the app layer, we use WebLogic Marketplace, again, as a minimum 3-node WebLogic cluster using GridLink, which looks after the HA failover in a much more seamless manner. And if you are running more modern architectures, but also if you are looking to consolidate existing Java-based applications, and I did have a session earlier in APAC on how to move Java applications in OCI. Perhaps you want to watch that recording if you want a little bit more info on that. You can use WebLogic Marketplace for that, or use WebLogic on OKE or Oracle Kubernetes. That is also a brilliant new architecture in OCI, which you can use either for Java-based applications or your own microservices-based developed applications. So on to our challenge and use case. How are we doing with time? 20 minutes, very good. So I did ask for an hour on this session because it's quite extensive. There's a lot of information, a lot to take in. Hopefully you can see how the platform has evolved from on-premises into our thinking onto OCI, and hopefully you can apply that with any, whatever you see fit. I should have pointed out also in the beginning of the session, but I think it's highly relevant here as well, that the architecture can be applied, and this use case can be applied for your platform all the way from, although it's a 19C based presentation, you could apply all these principles from 12C release 1 all the way to 21C. So none of that is highly version specific. There are some subtleties and benefits as we move from 12 to 19, i.e. the 3 PDBs, but in terms of the basic foundational architecture, you can still apply that all the way from 12C release 1. So if you do have some of those systems in 12.1, either in extended or perhaps in sustaining, you can still use a lot of those principles. But not to delay this, the challenge in our use case, back to original point, 15 distribution centers in January, 14 currently live. We need to be able to complete 98% of our picking transactions in no more than 1 second, while at the same time provide to all these 14 depots real-time operational reporting capability. All these reports need to complete in less than a second as well, with a real-time copy of our transactional system. So we can't affect the transactional, but we need to also give operational reporting the same capability. Also, give the support center the analytics capability to run their own kind of all-up type querying. The third important part is we want to be able to do zero downtime upgrades. So using Goldengate, we can enable that. So what does that look like in a 12C release 1 or release world? Well, let me take you through that architecture, which also applies, as I said, in 19C. So we've got 2 data centers, which are represented by each of those verticals. So you've got a highly consolidated two-node rack cluster with 7 of our depots running in one cluster. That's the active standby in data center 2. We've got a second set of 7 depots running in that cluster in DC2, and its active data guard standby is configured back in DC1. So we use, as you can see, both data centers as active data centers, and we split our deployment in both. So 7 depots are serviced out of one cluster and in DC1, and 7 depots are serviced in DC2 in a second cluster. The reason for that is that if we were to lose completely one of the data centers, we want to fully impact only half the logistics network. So that was a conscious decision. The third cluster at the bottom here, if you can see, this is our supply chain intelligence, or our real-time operational reporting system, which consolidates through Goldengate 7 plus 7. So all 14 depots are consolidated into that real-time operational reporting engine, which itself has got an active data guard standby onto DC2. Now, a little bit more about this. Hopefully, this is clear to everyone. This is one Goldengate source replicated into our Goldengate target. This is the second Goldengate source replicating into Goldengate target. Now, each depot runs out of a distinct application instance in the application layer, which points to a pair of database schemas. So those schemas, if you can imagine, these pair of schemas represents one application instance. So through schema consolidation, originally that would run as a consolidated rack database. Now these schemas, these 14 schemas, or should I say 28, are replicated and consolidated onto a single repository. And in the 19C world, this looks exactly the same. There's no different other than the Oracle versions, which I will explain in a minute. But onto a little bit more detail about that architecture. As I said, it's an active deployment. Each depot runs out of a unique application instance in a pair of schemas using singleton services. So there's 2 components to the application. One component will run as a singleton service in instance 1 in rack cluster 1, and the second application instance will run on instance 2 as a set of singleton services. That way, we've got full HA in terms of availability, but also we can scale much better in that way. The depots and the instances are balanced through all nodes, but also we can apply more nodes if we want to scale horizontally, or we can also scale vertically for more load. In terms of Goldengate, the way we have configured this is that each depot instance, if you remember, each depot has got its own schemas replicating onto your Goldengate target. Each depot will have a distinct extract, pump, and replica. That way, we can resolve any issues, either syncing or patching or upgrading of that, or configure slightly differently each depot if we need to, perhaps add more tables to replicate without impacting each other's sites. So eliminate all single points of failure. That way also we can scale, back to our scaling conversation, both vertically and horizontally. So you can run more extracts and pumps. If you add more schemas, you add more pumps, you can scale both ways, vertically and horizontally. We do use Active Data Guard Snapshot Standby to resolve data issues. So we had a case which I have blogged about in this, and the blog is underneath there, the link, where one of our application guys that tried to deploy some code took out one of the schemas, or at least should I say corrupted one of the schemas. And because we were in a highly consolidated schema consolidation fashion, we were able to use Snapshot Standby to flash back the database to just before the data corruption, extract that schema, and recover the schema in production without affecting any other site. Second important part of using Active Data Guard is we can use it for the Goldengate target if we need to take Goldengate target down, either for patching, although we can patch one node at a time. Sometimes you have to take both nodes, or if you have any issues with syncing or lag issues that you need to resolve, or perhaps you cannot resolve and then you have to reinstantiate. Hopefully, again, for those with Goldengate background, hopefully you understand what I'm talking about when I'm talking about Goldengate reinstantiation. Then we can automatically point the application to an active data guard standby for that schema, whilst we are resolving the synchronization issues. So there's no downtime for the real-time operational reporting for just a small period of time. And then when the issues are resolved, then we point them back to the Goldengate target. We do that through services, very simply, very effectively. As I said before, the architecture can be applied on 12C, on 19C, on 21C, either on commodity if you are running on-prem with commodity hardware, on Exadata if you are Exadata shop, or OCI and DBCS. Other considerations outside of the database component, which I think I've exhausted, is we do run quality of service on our network to protect and prioritize the voice traffic from the DCs onto the from the distribution centers onto the data centers. And we use dedicated compute and storage for the app layer, the DB layer. There was a strict certification requirement that the DB layer should run as physical, not as virtual. Just a little bit about Goldengate. For those that are not familiar with that, it's part of the MAA portfolio. It's integrated very well with Oracle Database 19C, or 12C, all the way to 19C and 21C. It is a log-based change data capture technology. It is used for heterogeneous replication between source and target. You can have Oracle and non-Oracle source and target. You can have different versions of Oracle for your source and target. And it's declarative. You don't need to write any code. It's all configuration based. So you set it up, you configure it, you set up whether you want to replicate the whole schema or a subset of your schema, and you don't have to develop any code to do that. And there's two types of architectures: the classic architecture and the microservices architecture. Classic architecture looks like this. So you got a source with an extract. The extract basically mines the logs and generates trail files which is part of your source schema. The pump will pick up those trail files, will send them across over TCP/IP onto the collector process on your target database. Those trail files will arrive there, and the replica process will apply them to the target database. There is a manager, and GGSCI is the admin tool to manage all those services. Same for source and target. Why use it? As I said, for our use case, it's unidirectional and consolidation, but there are other patterns which are bidirectional, so kind of a multi-master replication or even load balancing. How did we decide to use it? Well, we evaluated it with Active Data Guard, but we decided that for the cost differential, the capability that it provides us for replication, both the fact that we can run different versions for source and target, the fact that we can replicate less than what ADG does, and also the target is open. We can optimize it. We can add more tables if the application requires that. We can also add additional indexing. We can run materialized views. We can do all sorts of things. Also, we can use it for online upgrades, which you can easily do with DG. And for that cost differential, I think it is worth the investment. Also, huge benefit if you are licensing it on-prem. the Goldengate license does allow you to run ADG, which is also a benefit. I think I've covered that. It's mainly the pattern is real-time operational reporting, but also online upgrading. And we've integrated it well with RAC DataGuard in the MAA Platinum level. Just to give you an idea of the scale we're running, we are picking at around 5,000 executions per hour constantly across 14 distribution centers, and all these are completing in less than a second. How did we implement it? Well, several scenarios, and because I'm not really familiar with our audience, kind of their background, I'm just giving you all the information so you can apply it to any version from 12 onwards all the way to 19 and 21C that you see fit for your own platform. So original implementation, schema consolidation on Red Hat 6.5, 12.102. DataGuard fast sync we use for that. We saw that as the best option, more performant. DBFS to protect your trail files, and grid infrastructure agent, the important glue that connects and manages the services, the Goldengate services between Clusterware and the DB. If you're doing this on 19C, we've implemented it and successfully with Red Hat 7.5, DB 19.3, RAC again, same setup, DataGuard, fast sync with 19.3.01. You do have to use the latest grid infrastructure agent 9.1, but again, same type of architecture. For classic architecture, use DBFS to cover and protect your trail files. This is very well documented on how to set up, so you don't need to do this yourself. In terms of our Goldengate operations, the all important things, what should things look like in your cluster services? So you will see these DBFS mount resources, one per node. So this is on a two node rack cluster. So there's two of those resources, one per node. You'll have two Goldengate VIPs. So one Goldengate VIP per node, one Goldengate resource per node, one Goldengate service per node. The rest is quite familiar to all the rack administrators. Again, the second node will look exactly the same. And the target, again, will have DBFS mounts, Goldengate services, Goldengate VIPs, Goldengate resources. In terms of the dependency, how to stop and start. So basic management, you use AGCTL out of the grid infrastructure agent to stop Goldengate. So you stop first the service, then you stop the DBFS mount resource through CRSCTL, then you stop the actual VIP through CRSCTL, and then you stop the database. This is the right order because of the dependencies. In terms of starting it, you can start the service, the DB service, that will pull up all the resources because of the way they've built. They build with dependencies, so you don't need to start them in the same way you have stopped them. So starting the service will pull all the resources in the right way. Sometimes the actual Goldengate services might not start in the right node, so you may have to relocate them yourself manually. And how does classic architecture look? If you run GGSCI, which is the admin, the command line admin tool, well, as I said previously, we run individual extracts, pumps, and replicas. So this is the extract for one depot, AM depot. So that's the extract, that's the pump. And you can see we have a pair for each of those depots. On host 1. On host 2, you have something similar. The first line is the actual manager, but then you've got a pair, an extract and a pump for each depot. Same for the second source for host 1 and host 2. little bit different on your Goldengate target. So Goldengate target host 1, single process, R for replica. So again, that's just a 2-letter mnemonic, is one of our distribution centers. So there's 7 of those and 7 on host 2, equally balanced. How do you monitor things? Well, if you are looking for errors, ggserr.log is the equivalent of the alert log for Goldengate, and is your best friend basically. Everything is logged in there, so you will look in there for any errors or any inconsistencies. The way we have implemented this, as I said before, by having separate extracts, pumps, and replicats, that creates a separate report under GG Home on your directory report. So you can look at those reports for any further errors or more detailed errors. If you are investigating issues between either lag or performance issues, you have to look at overall how the database is performing through your AWR. So important to do that in combined with what's going on through your enterprise manager. If you are checking lag, this is a useful query to run the GG lag history. It is out of the GG admin schema, which is installed when you install Goldengate. Or should I say you install and configure Goldengate. So, for the heartbeat, if you run the query, it will look like that, and it will show you have you got a lag, or not. Goldengate microservice architecture. So that was all around classic architecture, which I think I've taken you through. The difference with the microservice architecture is it's fully REST enabled. There are some subtle differences, but it's built on the foundations of the classic architecture. The good things about it is it separates some of the duties between, if you like, Goldengate system administrators and Goldengate deployment administrators, if I can call these roles a little bit different. So you still have an extract, you still have a distribution center. Sorry, distribution server is now your pump process, but receiver represents the collector process, and replicate is still there to apply those trail files onto your target. The main difference is you have an extra process, the metric server, which is around performance management, and also service manager, which controls services from deployment. So in GGSCI, it's all or nothing. With service manager, you can actually, as I said, split those segregations of duties. Why did we use it? Well, it's far simpler to administer than the classic architecture. You've got a single web UI, single web interface for all your sources and targets. Great for efficiencies, for managing multiple deployments, especially if you've got over 100 deployments. It is built on classic architecture, so there's nothing significantly new. It's all the foundation is based on classic, and our benefits was the ease of admin for source and targets, also the troubleshooting and the monitoring of the configurations. But as I said, the fact that we can split the roles between system administrators and deployment administrators. It is also kind of a cloud enabling your on-prem architecture for future hosting and DC exit, which is where we are in our thinking. Some of the scenarios, we did a microservice architecture with 12.102 as the source and 19.3 as the target, as I was explaining in my previous slides. So almost like simulating an online upgrade. So that was one of the scenarios. The second scenario was a 19 to 19. So almost like the same, source and target at the same version, or source and target between 12 and 19. Again, all identical. important subtlety in order to manage your 19C Goldengate. You have to run 13.3 OEM. And the use cases that we've tested, it was from design to deployment is around 3 weeks of effort for the online upgrade. And we tested planned and unplanned scenarios quite successfully, which is quite an extensive task itself, because you do need to spend a lot of time testing source node failover, target node failover, the whole target node relocation, source database switch over to a standby, target database switch over to a standby. So there's a lot of test case scenarios that you need to consider. But as the title says, also there's we are looking. Our thinking has evolved from Goldengate 12C to 19C and now onto 21C. So this is a presentation in itself. So I won't spend too much time, but I just wanted to give you a couple of slides on where our thinking lies with Goldengate 21C. Now, OCI Goldengate 21C is a Goldengate. It's a cloud service, or should I say, it's a Goldengate cloud service, which is built on the microservices architecture, and it's a full PaaS service, which hides a few things from you. So you don't need to worry about pumps and what does the pump do. And you don't need to worry about the collector or the replica. You can still have access to the trail files and investigate those, but it's mainly user interface driven. There is REST APIs to script it all yourself, but it's all based on a single web UI configuration to set up replications between your source and target in a quite simple fashion through OCI. So why would you use OCI Goldengate 21C? Well, we started looking at it and testing its capabilities. It is built on a remote and capture delivery. So if you look at my presentation, this is mainly where we install agents on each database node. That's the classic architecture and also the microservices architecture. But this is based on a new, more strategic architecture, which Oracle is pushing for Goldengate, which is called the hub architecture, which is based on not installing not deploying agents on source and target. It's mainly installing Goldengate as a hub or as a middleware, and use remote capture for both source and apply and target to capture trail files and apply them to target, but the actual trail files are actually staged in OCI. Or if you were doing this on-prem, it will be your middleware. Now, the way you deploy this will be, the way you will size it is you will provision a Goldengate deployment based on your landscape. So again, small, medium, or large, your landscape, it depends what is the redo per hour rate. So for small redo rate, you will start maybe with 1 or 2 CPUs. For a medium redo per hour rate, so kind of the 50 or 60 gig per hour, you will provision 4 CPUs. And for larger deployments, you're looking for 8 CPUs or more. But you can start small and then use auto-scaling. The two use cases that we're looking at is the on-prem to OCI and the on-prem to on-prem. And the first one is obvious because you're looking to migrate from on-prem to OCI. The second one is if you are looking to drive some efficiencies on your Goldengate costs. So one of the use cases I was looking at is obviously you provision OCI Goldengate in this fashion in a private VCN, by use peering, and you use Fast Connect to manage your source and target. So if you remember my architecture, this is an on-premises 1, on-premises 2, with our standbys and SCI as the real-time operation. So we can do exactly the same thing with OCI Goldengate as opposed to the individual installed Goldengate components, and drive some cost savings. Moving on. Again, as I said, this is a presentation in itself, so I will build a separate presentation, hopefully in the next Oracle Groundbreakers session, just to take you through how to deploy and use Goldengate, OCI Goldengate, which is 21C. MAA and Oracle Multitenant. Well, why would you use Multitenant? In our deployment, mainly we've used schema consolidation. Multitenant, we've started deploying it with 19C, and we're looking to capitalize more on the fact that we can now run up to 3 PDBs. Why is it attractive to us? Well, it's attractive because we can run. We have the ability to map schemas onto tenants. We can flashback PDBs without affecting. If one schema represents one PDB, we can recover and we can protect resource allocation on one PDB without affecting others. The key important thing for us is we can test data guard switchover onto PDB level, or we can use data guard switchover at the PDB level and satisfy our audit and risk requirements once every 6 months for one depot. Autonomous, and why would you use autonomous? So that's part of our database reference architecture now, and the where we see that fit for purpose is the externally facing applications mainly. So that's where we started seeing a valuable use case, where you have an externally facing application currently that is serviced through the DMZ. It's a good fit because you can actually take advantages of all the automation, the automated security patching and from a risk and audit perspective, and from a compliance perspective, because of the amount of security fixes and patches that you have to apply on a monthly basis, and sometimes even on a weekly basis. We do like it because of its high degree of automation, but also on its auto-scaling capability. It is your quickest path to Exadata. I must admit that you can get, within 5 minutes, you can have an Exadata instance. Challenges? Well, serverless option is shared. So for mission critical, I would recommend that you also look at the dedicated. But I do like, and I have tested this and I have deployed this extensively. I do like the autonomous data guard. With a click of a button, you've got a disaster recovery set up within both same availability domains within one region, or a multi-region if you are using ATP dedicated. Some specifics for your use case, which also apply to our use case, is you need to rethink how your batch code is implemented, because there's less tooling involved in ATP, so SQL Loader is not available. You can use external tables, you can use data pump, you can use other tooling, all Goldengate, but you can't use traditional SQL Loader. All PLSQL procedures that write into your UTL file destination, you have to use DBMS Cloud package to rewrite those, and by creating an object stored in a private package. Disaster recovery, I think I've covered most of that very extensively. We do a full data center switchover at least once a year for all 7 depots. That's risk and audit requirement. In terms of Goldengate 19C, the failover of the source is quite straightforward. The target is a little bit more complex. The mechanics behind it are dependent on a database link, which connects your target VIP, your target with the source. There is a DBMS schedule job that fires with a role transition trigger. So when your target database moves from primary to standby, a database trigger fires a DBMS schedule job that fires another job at the source to change the target VIP. If you're thinking about it, it's in the source needs to start pointing to a new target VIP, so it needs to change the source's Goldengate VIP target onto your new VIP, and then restart the manager and start pumping the trail files onto your new target. So that's a little bit complex, and you need to make sure you implement it right. It's very well documented. So again, you don't need to do the hard work yourself, but you need to test it extensively. In terms of our Oem architecture, it follows exactly the same, architecture of your mission critical platform. It's an MAA Platinum with 2-node rack cluster at the DB layer and 2-node OEM, or should I say OMS layer. We are using always-on monitoring in case we need to bring OEM or OMS down. We still receive notifications. It's a lightweight Java application. I would encourage you to use it. It's easy to set up, and it will save you a lot of trouble when you do OEM patching. Lessons learned. Well, prove it works. Don't leave it to luck. Make sure you look at this document ID for your schema validation. Not every database schema is a good Goldengate candidate, so that will give you a good validation of some of the data types perhaps that are not supported. As I said, future plans for us is the OCI deployment, looking at Goldengate Hub architecture and Goldengate 21C, OCI Goldengate, i.e. 21C, some of the latest and greatest Oracle features with the AHF and the fleet home provisioning for the patching. Also migrating from Red Hat to Oracle Linux to apply zero downtime patches. The MAA journey for COB has paid off. We've had planned outages for server BIOS upgrades. I can probably count 6 or 7 in the last 18 months. We've had unplanned outages, hardware failures, CPU board replacements, memory DIMM failures. With COVID, we were able to scale vertically and horizontally, both with demand, but also as logistics network grows. I should have pointed out that we have started with 12 distribution centers, and now we are on 15, with a lot of transformation in place. We were also able to cover human error and through the snapshot standby, and with zero business impact on our mission critical, both mission critical transaction platform and the real-time operational reporting. So the MA investment has paid off for the COP, and I've been quite vocal about it in the social media, which you can have a look and feel free to connect. A little bit about MAA on Platinum, you can look into that. And this is me. Thank you for listening. I will be happy to answer any questions. I think we've got a minute, maybe. So thanks for listening. Thank you for having me.
Hi, Nikitas. Thank you so much. Very complete presentation, excellent content. Thank you so much for sharing all this with the community in the Asia Pacific and now around the globe. Up to this point, we don't have any questions. I'm just waiting a little bit to see if anything come through. In the meantime, thank you so much for waking up so early in the UK to give us this great presentation. And apologies for making you suffer being so early.
No worries. It was a pleasure to present. Thank you for having me, Francisco. I will look forward to perhaps any questions, or if, as I said, if anyone wants to digest the session after it's been placed, after the recording is made available, they can reach out to me on social media, either through Twitter or LinkedIn.
Fantastic. No, that's great. Yes, the replays will be available until the 30th of December, and everyone can digest with calm. You have 110 slides. That means the people have a lot of information to digest.
Yeah.
And
yeah, I have to apologize, but I wanted to give as much as I could to the audience, because they could be running different versions, and like myself, we've started with 12 all the way to 19 and now 21, and perhaps not everyone is in the same journey, and they can apply as they see fit in their own landscape.
No, it sounds good, and for sure the community appreciate all that and all the effort put in your presentation. And well, looks like there's no question coming, but for sure you will get plenty to receive and after the people digest all this. And thank you so much, Nikitas. Please, you and everybody listening, please take care and be safe on these crazy times. Hopefully next year we can see each other face to face and everything start coming a little bit closer, what we will call normal.
Indeed, looking forward to that as well. Looking forward to some face-to-face and on-site sessions.
Fantastic. Thanks so much, Nikita. Have a wonderful day.
Thank you. Thank you, Francisco. Same to you.
Bye-bye.
Bye-bye. Bye-bye.